So this lesson is going to be about quadrilaterals. And so with quadrilaterals, there's a lot of nitty-gritty details we could get into. But I'm going to concentrate on some of the big pieces of information that I want you to take away with the quadrilateral. And there's a lot of, like I said, nitty-gritty details. So in your geometry workbook, you have 4 pages dedicated to quadrilaterals. 2 pages are these property charts. And then 2 pages are where the properties have been written, and then I have sample drawings. So I'm going to start on the second 2 pages first, kind of work this backwards in this scenario and kind of talk about the relationships, and then we'll talk about the highlights and what I really want you to know about each of the shapes. And so with the quadrilaterals, essentially there are 3 branches of quadrilaterals. We have our parallelogram is the most common branch. The parallelogram are all the shapes that are 4-sided that have parallel sides. So a parallelogram is kind of your tilted set. Then when they are upright and they have 4 right angles, then you have a rectangle. And when it has 4 congruent sides, then you have a rhombus. And so then when the rectangle and the rhombus are combined, we end up having our square, which is our square has 4 congruent sides and 4 right angles. The next family we have are what we have, the ones that have 1 pair of parallel sides. So that's the trapezoid family. So trapezoids have 1 pair of parallel sides. Like in this picture, the top and the bottom are parallel, but the sides are not. So we have trapezoids, and then we have isosceles trapezoids. Isosceles trapezoids are a special type of trapezoid in which the 2 sides are equal. And then the third family we have are the kites. That's the family, it's kind of its own solo quadrilateral that has absolutely no parallel sides. So that's kind of the 3 division families we have of the quadrilaterals. So let's first start with the parallelogram family. So the parallelogram, again, I said opposite sides are parallel. So that's one of the key things you need to know. Opposite sides are running parallel with each other. And because they're running parallel with each other and they are all connected, they're also going to be congruent. So opposite sides are congruent and parallel. So the single arrows represent parallel with each other. The double arrows represent parallel with each other. The single lines represent congruent with each other, and the double lines represent congruent with each other. The other important part are the angles. Opposite angles are congruent. So the nice thing about that, if I know this angle's 50, I know this angle's 50. If I know the other corners, then I would know if I have 50 and 50, that's using 100 degrees, I could then subtract from 360 and then divide it in half. The other relationship I have within the triangle or the parallelogram is that these parallel sides take us back to unit 3 with our parallel lines cut by a transversal. These sides are transversals. So what that means is as I go around this shape, the angles should add to 180 degrees. That's because they're those consecutive interior angles. And so those always total 180 degrees. So those are really the big important parts about a parallelogram. The only other statement here that's also sometimes comes into play is that if you draw in the diagonals of this parallelogram, so I'm going to just use an orange line here, and if I draw in this orange line and this orange line, what that does is it creates equal sections on these diagonals. So when you draw in the diagonals, they do bisect each other. That's probably not a relationship you will see a whole lot of, but it does exist. Now, when we go to our rhombus, now all the sides are the same around our rhombus. Everything we had in a parallelogram is true. All of these relationships still hold. Parallel, parallel. We also will get our diagonals, what we call bisecting each other or cutting them in half. Opposite angles are going to be congruent. But the other nifty little thing about a rhombus is when I draw in these diagonals in a rhombus, they actually will cut these angles in half. And they will form a right angle in the center. And so what that means is you get 4 identical right triangles. This is 1, 2, 3, 4. 4 identical right triangles. So all the rules of right triangles now get applied into a rhombus world. So that's kind of cool with a rhombus. Now, with a rectangle, what happens? Instead of giving 4 equal sides, we get 4 equal angles. And so with the 4 equal angles, they're all right angles. We still have opposite sides which are the same. And then the diagonals will bisect each other, but the other nice thing about a diagonal, they not only bisect each other, but they're all equal. So that means all these parts are all the same. And so when you have rectangles, it creates 2 sets of isosceles triangles, one top and one bottom, one left and one right. Because a rectangle folds vertically and horizontally. A rhombus folds on the diagonal. And then finally we have a square. I apologize that the square that's here represented in your workbook doesn't exactly look very square. It looks kind of rectangular. Probably should be shortened up a little bit there. But with a square, what's nice about that is you have the 4 right angles in the corner, just like you have with a rectangle. But when you divide in a square, you also get 4 right angles in the center, and all of these are bisected. So with a square, you never guess about the angles. That's why when you'll hear like somebody doing carpentry or building work, they'll talk about I need to square it up. It needs to have all of these relationships. It needs to have what we call 45, 45, 90 triangles inside of them. And that's a very common relationship with a square. All 4 of these parts are identical, and all 4 outsides are identical. So you end up with 4 identical 45, 45, 90 triangles. So that's the relationship of a square. So those are the parallelogram families and their properties. Now let's talk about a trapezoid. So with a trapezoid, the only thing we know is that the top and the bottom are parallel. And because those are parallel, these 2 angles total 180 degrees, and the 2 angles on the left total 180 degrees. Now, if we make it isosceles trapezoid, we still have the top and the bottom running parallel, but now we have 2 sides that are exactly the same. And just like in an isosceles triangle, when you have 2 sides of the same, you're going to have 2 angles that are the same. And you're going to have 2 angles up here that are the same. The other relationship that sometimes you get in an isosceles triangle or trapezoid that people talk about are the diagonals are congruent. It's probably not real useful for anything we are doing. And then the last is our kite. And so a kite has no parallel sides. What it has instead are adjacent congruent sides. What that means is the 2 that might be what you might consider the shorter sides are the same, and the 2 longer sides are the same. And just like a kite that you might have built when you were a little kid where you put 2 sticks together and then you put the paper on the outside, you get these right triangles. And when you have those right triangles, a kite folds down this line of symmetry, and so my angles all get split. So those are our relationships we have for a kite. So what we want to be able to do is apply those relationships to certain questions. So please check out Schoology, and we will go over a few examples of such.